Hello, this is Ashley, and this is the last lab for 2211, choosing your own adventure. So in this lab, we could choose whatever physics topic we wanted to apply to a real scenario. So I chose to examine collisions. So the purpose of my lab in particular is to observe properties of objects in collisions and identify what kind of collision they are. And specifically, we're dealing with object balls in a game of pool. So the main principle is conservation of momentum. So it kind of just outlines how the initial momentum is equal to the final. So momentum is conserved. And then there's different classifications of collisions, inelastic and elastic, based on if kinetic energy is conserved or not. So on the right, there's a formula for the total momentum before and the total momentum after, and then being equal. So delta P equals zero, and then the same thing for kinetic energy on the bottom. So just a little preview, I did classify the collision identified in a video I got from online as inelastic, and I'll talk more about that later. So I got this video from the internet and it's playing right now. It's just a cue ball striking an object ball, and I got some tracker data from that. I traced both balls, as you can see, the red and the blue little dots there. And then as a result, graphs were produced, and then there's the data table on the bottom. So using the tracing feature, I just tracked the motion of both of them, and then those graphs kind of helped me determine whether or not momentum was conserved and whether or not kinetic energy was conserved. So I did not choose to use a coding component for this lab. However, if I was to, I would have to initialize the position vectors and then the velocity vectors, momentum, and mass. So I'd probably just search up the mass of a regular cue ball or object ball. And then initial momentum for the object ball would be zero, and the initial momentum would be whatever initial speed the cue ball had. And then within a loop, I would just keep updating position and velocity, and then also update final momentums. So at the end, calculating delta P and delta K um, would kind of allow me to classify um, the whether or not momentum is conserved, and then whether or not K is conserved, and then whether or not it's an inelastic or elastic collision. So, my final result after calculating initial and final kinetic energies, I discovered that delta K was close to zero, so like zero point 0.1, but it wasn't quite zero, obviously. So, um, therefore, I chose to classify the collision as inelastic, but not maximally inelastic since the balls did not stick together. And then momentum was conserved since in all points of the trajectory, the total momentum equaled the initial momentum at the beginning of the video. Um, so one possible source of error was just tracking. I think there's always um, some source of error in judgment based on where you choose to put the center of mass and whether or not the center of mass is in the center of the ball. It's kind of hard to say. And then another possible source is that there could be friction on the surface of the pool table because it's not just like a slippery surface. There could be some roughness contributing to the slowing down of the balls on the table. So, some what if questions I came up with is kind of what could be a reason that there was a change in kinetic energy. As I kind of mentioned before, friction could have done work on that system of the two balls. Um, And then also, just the kinetic energy could have been transferred into heat or just sound waves, um, which would result in kind of like a really, really small delta K, anyways. And then the second question is, does the spin on the ball change the trajectory of the object? It could change it because it adds angular momentum to the ball. So its trajectory could be slightly different if there was no like top spin at all. That's not something I could really tell from the video. However, in real life, it could be a factor in changing this trajectory. Thank you.